Okay, so here's what we're going to do. Activity 1 says, how can a graphing calculator help you find the solution to a system of equations? Consider the following system. Now, personally, I would solve this system algebraically, but we're going to learn how to use a calculator because there's certain skills in the calculator that I need you guys to know. Now, Desmos, super easy. Type in like the way it looks, see where they touch. You're good, right? But we're using graphing calculator instead. So let me pull up my graphing calculator as well. Have a computer version of one. Try that one, that one. Yes, perfect. Very good. Okay. Now, actually, before I get too carried away, the problem. There are 3 scenarios that could happen when you have 2 lines. Well, actually, let me back a little bit. Why are these 2 lines? So why are both these equations representative lines? What's it tell? Well, not so much that, but let me see with the variables. Yes, it is a system, of course, but why is each equation a line? You do. What do you notice with the variables? Do you see the exponents? It's just a plain old x and y, exactly, right? If you see plain old x and y, you know it's a line, right? If you see like x squared, that'll be a parabola, right? Or something else, right? Now, so we have 2 lines. Okay, we're good on that. Now, we have 2 lines, there are 3 things that happen. The lines could cross, or they could be parallel, or they could be the same. Now, looking at these coefficients, in order for them to be the same, everything has to be identical or proportional. Like if that were 6x plus 2y equals -6, they'd be identical, right? Because they're proportional. It's just the second one times 2. If they had the same coefficients for x and y, but different constants on the other side, let's say 6x plus 2y equals like 40 or 50 or something really random, then they'd be parallel, but different y-intercepts. But here, every time pretty random, right? They're not proportional with different numbers. For the most part, 2 lines will touch once, right? That's what we expect. So I'm expecting that to happen. Okay, so now I'm going to go to the calculator, turn it on, go to y equals, and we're going to punch in the equations. But before we do that, there's some work we have to do. What work do we have to do before I punch in these equations?
Y-intercept.
Yeah, you got to get y by itself, exactly. So we have to get it in slope-intercept form, or y equals mx plus b. 100%, y equals mx plus b. Now, Desmos, again, you type the way it looks. It doesn't matter. But graphic calculator, you have to get y by itself. So a little of algebra you got to do. Not that hard. I know you guys can handle it. Okay, that's cool. Here, that's cool as well. Okay. Now let's plug it in. Okay. First off, before we graph, make sure you punch everything correctly. The last class, it was good. I'm glad the last class made a lot of mistakes, but I was like through the activity and people were still like, wait one second, I didn't even get the graph at all because they were doing some mistakes. Let me walk you guys through the potential pitfalls. So when you do a negative in front of the coefficient, like -3, for example, for the coefficient of x, are you going to do that negative with the parentheses around it or the minus sign between plus and times? Which one are you going to do for a negative symbol? You want to do that one. Yeah, the one in the lower right corner. What does that one do? The one I'm pointing at right now. That's subtraction, exactly. So you want to make sure you don't mix these up. And again, you guys are still getting your bearings straight with the calculator. It's all good if you're making mistakes. But what happened was, like, well, for example, one student did this. One student had that. So what does a calculator think when it sees that? It sees that, oh, I'm doing -3 times x times -3. So it's going to graph 9x. It's not graph it's supposed to be. It's going to graph 9x, right? How does a student do that? How does a student also do this during class today? They did 5x with -35. So what the calculator thinks, the calculator is incredibly stubborn. It thinks of, oh, I want 5x times -35. So it's going to graph y equals -175x with a very steep slope that's negative. That's totally against our intentions. We don't want that at all, right? We really want to be proper and say, yeah, 5x minus 35. negative 3x minus 3, right? Now, I also had some students do this. Instead of putting a negative symbol, they did the minus symbol. And when they tried graphing, they got an error and didn't know why. Why are you getting an error? Because the calculus is saying to itself, okay, I want something minus 3. Well, tell me that something. So it's freaking out because it wants to subtract the 3. It's not treating this as a negative. So you got to change that minus sign to a negative. So you got to make sure you differentiate between those two. Very important that we get this right. So there's a lot of different ways. Some people like, I mean, honestly, I see some random crap. Like someone just had a bunch of plus signs here. Of course it's going to error. The calculus is going to like, what do you want to do with that? So we had to go and clear it. So there's all these different reasons you could get errors. If you get an error, please let me know. I'll come on. And you know what? Be creative if you have an error. Maybe I'll discover something I've never seen before. I don't know. All right, let's hit graph. I'm going to graph this in the standard window. So to do the standard window, if you hit zoom and then standard, it's going to go from negative 10 to 10 for x and negative 10 to 10 for y. So I'm going to deliberately graph in the standard window. So I hit zoom. After I type in the equations, if I go zoom option 6, okay, I see the lines, but I don't see them touching. How come I don't see them touching? Yeah, it's further down. Like that one is, you have an error?
Yeah.
Good. I want to see it.
So weird.
So negative 3x, but I'll get there in a second. So that's negative 3x minus 3. That's good. This is supposed to be 5x minus 35, but this is only going down to negative 10, right? You count it. Negative 1, negative 2, negative 3, negative 4, negative 5, all the way down to negative 10. It's got to touch way down here somewhere. So I got to change that. I'll change that in a moment. Do you know how to change it? Let's switch out.
Yeah, this is what I would say.
But you, that's all. That's why. You just got to change that back to. There we go. Yeah, you good now. Yeah, you good. Oh, let's reset the window. So go to zoom option 6. And also let's turn off. Turn off mod off. Okay, anyone else have problems? No? All right. Okay, now the problem is that we can't see the point of intersection, right? Because one has a y-intercept of negative 35, and this goes down to negative 10. This is what I need you guys to do. This is where I need you guys to kind of follow along very carefully. So if I go to window, window allows you to change the well, the window. Pretty much. It allows you to change how wide or how tall or basically how it enables you to see the graph, put it that way. You can see the graph depending on what you change. So I want to change x so much. I think the x is fine. So negative 10 to 10 for x, that's okay. So I'll keep x min negative 10, x max at 10. X SCL stands for scale. That's the width of each tick mark. That's fine. That's okay. Now y min, y max. I think the y min I should change. Because right now it's going down to negative 10. But I really need to see that. So let's change this to negative 40 maybe, just to guarantee that we see the first line. So I'm going to change it to negative 40. Y max, I'll leave it alone. Now the y scale won't matter, but if it's easier on the eyes, it's better to have the tick mark spaced out so you can count more easily. So right now, if the scale is 1, you go from negative 40 to 10. How many tick marks do we expect from negative 40 to 10? 50. 50. Yeah, it'd be 50, right? That's a lot. Maybe change it to 10 or 4 or 5, just something more reasonable. It won't matter. The graph will be fine, but and I don't know what XRes does, so I don't know what that does. So maybe this is like how quickly it plots the graph. I don't know. I don't know what those things do. So I'll hit graph now, and now I can see it. So I see that first line, and I see that second line, right? Okay, so we've taken care of that. Now we got a good window. Again, all you have to do is hit window and just change some of the numbers so they're more proper for the equations you got. Now, we want to find where they touch. If you hit trace, the cursor will appear. If you hit the trace button. And you can move the cursor close to where they touch, but you're not going to be spot on, unfortunately. Like, if you had to guess what it would be, like, what do you think it's roughly? 4, negative 15, probably, yeah. That sounds about right. Okay. But is there a way we could do it more accurately And the answer is yes. Yeah, good. Okay, yeah. Actually, well, second trace. Yeah, so here's what you do, guys. This is where I need you guys to really follow along so you guys don't get lost. All right, so here's what you do. Hit second trace. Now, second trace is called the calculate menu. Has a lot of cool features that you can do with graphs. You could find the y value for any x value you plug in. The zeros means the x-intercepts. The mins or maxes, high and low points. That'd be great for parabolas if you want to find the vertex or other types of graphs that have like high and low points. Clearly, we're interested in option 5. So we're gonna do option 5 in just a moment. 6 and 7, don't worry about it. That looks very cryptic to you guys. That's calculus. It'd be very helpful when you get the calculus in 2 years, but for now, we won't worry about 6 and 7. So I'm gonna pick option 5, hit, and obviously select it, or just select option 5. Now, it's gonna ask a bunch of questions. It's gonna ask like first curve, second curve, guess. Just hit enter 3 times. I'll explain what those questions mean in just a little bit. Enter. And so it gives me the answer spot on, 4, -15. Let me do it again, because I know you guys, sometimes it takes people a while to figure out what's going on. We did y equals, we changed the window, we did graph, we want to find where it intersects, second trace. So second's top left corner, trace is in the top row. Select option 5, hit enter 3 times, 1, 2, 3. Boom, there you go, 4, -15. So it gets to the answer. Now, why is it asking these questions? Let me do it again. Option 5. First curve means the first line or the first equation. Even though these are not technically curves, these are lines. They call them curves. So usually what you do is you move it close to where you think it's going to touch, hit enter. For the second curve, if you hit the left or right, you can see we're there. You could hit up and down to move to the next line, but hit enter again. And guess, hit enter again. Now, why is the calculator forcing us to go through that process? How come it just doesn't tell us? Like Desmos is nice. Desmos, just mouse over. You find the points of intersection. In fact, actually in Desmos, what if you have like some really wacky graph? You have like 5 points of intersection. Just mouse over to those 5 points of intersection and record them, right? But here, it's why do you think it's forced to go through all these questions? What if I didn't have 2 lines? Did you break something? No. Okay. Just be careful. All right. What if I had this here? Just because I feel like doing this. Actually, let me switch that to a -1. Okay, how many times are these touching? That horizontal line, how many times is it touching that graph? 4 times. So I hit second trace, option 5. We have a bit of a conundrum. Because what point of intersection do you want to find? You have to choose. That's why it's asking these questions. Unfortunately, today for calculator forces you to find each point of intersection 1 by 1 at a time. So that's why it's asking those questions like first curve, second curve, guess. Because you have to move the cursors wherever you want to find the point of intersection. Let's say I want to find one on the far left. I got to move that cursor very close to it, hit enter 3 times, then I get the answer right. So that's what it doesn't just tell you. It makes you go through these questions. But if you're doing something as simple as this, I just kind of just blindly hit enter 3 times, so I know it's going to get to the answer. That's the reason why it does that, just in case you're curious. For those who are doing SAT later this year, those who are juniors, thankfully they have Desmos now built into the SAT. Just use that. Don't have to use a calculator for this stuff. One of these days, we'll allow Desmos on our test. I don't know when that day will come, but I think it's going to happen eventually. Maybe next year or 2, I don't know. But right now, we got to use the calculators. So, got to understand how it works. Okay, lastly, discuss 2 methods with your team of how to solve these algebraically. Okay, let's just do it really quickly. I'll just do it with you guys, and then we'll move on to activity 2. And let me make sure I'm good on time. Yeah, we're still good on time. Okay, cool. So algebraically, how would I solve this algebraically? What could I do algebraically? Sam, go ahead.
Elimination.
Totally, 100%. I love that. Yeah, what if I just add these equations together? 8x equals 32, right? X equals 4. That took like 5 seconds. Plug in 4 into one of these equations, solve for y, and look at that. I got my answer. So that's a great technique. Or what's another technique we could have done? Remember, we had this already, right? Totally, right. Set them equal to each other. Yes, good. If you set them equal, that could work too. Or isolate one of the variables and plug into the other equation. Either way, same thing. Work it out. It's going to be a-okay, right? You get 32, 8x, x is 4, boom, boom, boom. Yeah, it's good, right? So obviously, algebraic is more accurate. Graphing by hand, not the best. The calculator or Desmos will work if you, because it's a computer system doing it for you. But graphing by hand, that's going to be kind of messy if you're not careful. All right. Substitution elimination, exactly right. Actually, there are other techniques too, which we'll learn later in the year. There's something called a matrix, and that within itself has several other methods. We're not there yet. We'll get there in spring, but there are other techniques using other kinds of skills that you'll learn down the road. But for now, substitution elimination, graphing, those are the things we know. All right, so you and your table groups, this is perfect. We have good groups here. What I want you guys to do is work on activity 2. So you have 2 equations. Now, ignore this part here. Really what I want you to do is this. Go through these instructions. So I want you to graph, right? Graph each one. So let this be y1. Let this be y2. Adjust the window so you can see where they touch. I'm going to leave that up to you. Use the trace feature, and then use this feature also, which we already talked about, right? That's second trace. We know this now, right? Don't worry about the table feature. You could use that if you want. I don't care about that. So yeah, sure, yeah, totally. All right, so do this in your table groups. I'll come around and help you guys out if you're stuck. Work this out. These are gonna be 2 parabolas, by the way, right? Should only take a few minutes to talk about it. We'll go over it, finish off the notes, and we'll be good, right? Okay. Did you guys get? Well, why don't you tell me what you guys get? Good, Sam?
-2, 24.
-2, 24. What's the other one?
3, 9.
3, 9. Good. Yeah, so those should be the 2 points of intersection. -2, 24 and 3, 9. So if you graph both equations, you get 2 parabolas. Unfortunately, in the standard window, you're not going to see them touch because one of the y-intercepts is pretty large, it's 30. And the y-intercept is easy to tell. Just plug in 0 for x. Or just look at the last number, right? That's going to be your y-intercept. As long as everything else has x in it, the last number is going to be the y-intercept, right? So there needs to be an adjustment to the window. It depends. If the y-intercept's 30, then obviously make the y max at least 30, but make it maybe a little higher, maybe like 10 more, like 40, for example. But the y min, I would keep as -10 because I don't see any large negative values. That makes sense for 6 or 30, right? So let's turn it on. Y equals, let's do a 2x squared minus 5x plus 6, negative 2x squared minus x plus 3o. The Windows standard right now. So let's just see what happens if you do it standard. First one's okay. Second one, not great, right? So what I'm going to do is I'm going to go to Window, save, make that 40. Awesome. Now we'll be okay. Of course, I didn't change my scale. So be it. I should change the scale. Actually, let's change the scale. It's a little annoying. Let's make that 10. Let's try again. See, there we go. So you hit second, trace, option 5. See, that's where the questions do matter. 1, 2, 3. Okay, negative 224. Do it again, option 5, but move it closer to the second point of intersection. That's the first curve. Hit enter. Second curve's pretty much already there. Hit enter again. 3, 9. Now, if you solve it algebraically, you could do this. Substitute, guys. That's going to be your best way to solve that algebraically. And how would I solve this algebraically? What would I do? Yeah, combine like terms and factor afterwards. Exactly right. We got to do both. Both are necessary. How would I factor that? Before that, though, is there a Gray's common factor I could pull out? Take out the 4 first to make your life easier. Yes, you could totally go straight to the diamond, but it's gonna be a little harder. And then we do the diamond after that. The diamond means find two numbers that multiply to the middle number, sorry, the last number, and adds up to the middle one, negative 3 and 2. Some factoring will be harder than this. This one's pretty easy. So that makes sense. Those are the x coordinates where they touched. To find the y coordinates associated with them, throw it back into either equation to get the y coordinates that go with them. Remember, 3, 9 is one of them, negative 2, 24 is the other. So now we're seeing a lot of graphical algebraic connections, right? Graphically, see what's happening. Algebraically, see what's happening. Numerically, if you were to plug in random numbers and kind of figure it out, but that's not really the best way to do that. So, but yeah, all makes sense, right? All right, I think we're getting close to the end here. Okay, what do quadratic equations look like? They have x squared in them. They're also parabolas, yes. What is the format? Usually it's going to be like this. And that's called standard form. Okay, that's called standard form. That's the format. So quadratic equations, what makes them unique? They have a squared term. Linear is just plain old x. Quadratic have x squared. Cool. Good. All right. Okay, for number 2, zero product property. What this means is you want to factor, then set each factor equal to 0. Well, let's do it. How do I factor this sucker here? This is pretty easy. I don't need to do a diamond necessarily. You could just think about it. Two numbers that multiply negative 10 add to negative 3. What would that be? Say again?
Negative.
Which one's negative? Yeah, the 5 is negative, right? Be careful. And by the way, there are really not that many options, right? Like negative 1 and 10, negative 2 and 5, negative 5 and 2, or -10 and 1. So you kind of just list the options. If none of them work, guess what? It's not factorable. If it's not factorable, how are we going to solve it then? Plot form then, right? Or another technique called completing the square, which we'll talk about later in the semester, which by the way is used to derive the quadratic formula, but we're not there yet. So x minus 5x plus 2, that's pretty simple. So one of these two things has to equal 0. Either this has to be 0 or this has to be 0. One of those two things has to be 0. So what if I set the first one equal to 0? X equals 5. What if I set the second one equal to 0? -2. And those are your answers. That's why it's called the zero product property. Because are we doing a product? Are we multiplying? Yeah. Do I want 0? Yeah. How do I get 0 to happen? Either this has to be 0 or that has to be 0. Because anything times 0 is 0. So x minus 5 is one entity. How do I get that entity to be 0 when x 5? How do I get this entity x plus 2 to be 0 when x is -2? And it's that simple. That's why we have it. These are also x-intercepts. This also helps us graph the function, because now I know where it crosses the x-axis. And now I know where the vertex is, because it goes right between, because of symmetry. So factoring is actually kind of a key skill for math. You really need to know factoring to move on with math. So yeah. So we want to be good at it. And we'll, trust me, I will drill you guys factoring if we need to, because it's important. I did last year for sure. CPM doesn't do much drilling. I do. Because we need it. All right. Lastly, what is the quad form? You guys remember? What is it? Look at you. You got it. Yeah, you can make a song. You can say, whatever. Yeah. What is it used for? To find x-intercepts. Or we call them zeros. So essentially when y equals ax squared plus bx plus c, that's standard form. You extract a, b, and c from the equation, but very important, you have to have it in this format first. So if you're given a quadratic equation, it's just a bunch of random stuff, or a bunch of terms are not combined, combine them and collect them all on one side and get y on the other side. And then you're letting y be 0, right? If you try and find the zeros, that's when y equals 0, right? So you're deliberately changing that to a 0 and solving for x. And that's what it's used for. It's used for that purpose. Okay, good. We're perfect on timing. So we got what, 2:05? Okay, good. So the quiz is really short, by the way. You guys probably get it done in like 2 or 3 minutes, really fast. You get head start on homework after that if you like, or if you're just tired and want to relax, that's all good too. Let me stop the recording.